Hey guys, today we're going to learn how to find the derivative of exponential and logarithmic functions that have bases that are not e. So before we did the derivatives of any e to the e function, and we also did derivatives of ln functions, which are logarithms that have a base of e. So let's have a look at what these derivatives are. If you are finding the derivative of any exponential function, you're going to follow these rules. The first one is for a, some base, raised to the exponent of x. So for this case, this is just where the exponent is simply your variable, x. And the derivative of that exponential would be the ln of the base times that exponential itself. If your exponential has a base that is not x, so maybe some other function, in this case, I'm calling it u, then the derivative would be the ln of the base times the exponential exactly as it is, and you multiply it with the derivative of the exponent. So essentially these are the same thing. It's just that for this one, if your derivative is something other than x, you would multiply by the derivative of that exponent. So that's like a here. This is your basic logarithmic function where the exponential function, where the exponent is simply x. So the derivative y prime would be the ln of the base, which the base is 3, times the exponential, 3 to the x. So this would be my answer. For logarithmic functions, it's pretty much the same format, except your derivative is going to be a fraction. So for our logarithmic functions, the derivative, if your function here only has x as what's inside of log, then the derivative would be 1 over ln of the base times x. If what's inside of log is something other than x, so another function, which here I'm calling u, then the derivative would still be the same format, 1 over ln of the base times what's inside of log, but then you multiply that by the derivative of what's inside of log. So that's like this example here. This is your most basic logarithmic function where what's inside of log is just x. So the derivative here would be y prime is equal to 1 over the ln of the base, which in this case is the 5, times what's inside of log, which is x. This would be my answer, which you can also write this as 1 over x ln of 5. If you don't want to write the parentheses around the x. Either one of these would be correct. Now let's look at some other types of questions. For all of these, what's the exponent or what's inside of log is going to be something other than x. So that's what I'm calling u. Now sometimes I find it helpful to create kind of like a little table labeling what all of my components are. So a represents your base. For this one, my exponential, my a is the 4. U is the exponent, which is 3x. And then u prime is the derivative of the exponent, which is 3. So the derivative of this function would be y prime is equal to the ln of the base times the exponential exactly as it is, so 4 raised to the 3x, times u prime, which is 3. This would be my answer. And just to write this a little bit neater, we can move the coefficient to the front, since normally the coefficients are always written to the front. So 3 ln of 4 times 4 raised to the 3x. And this would be my derivative. Looking here at this logarithmic function, my base, which is a, is 3. My u is what's inside of log, which is sine of x. Then the derivative of sine of x is going to be cosine of x. So now we're going to follow this format. My derivative is going to be y prime is equal to 1 over the ln of the base, so 3, times u, which is what's inside of log, so the sine of x. And then all of this gets multiplied with the derivative of sine of x, which is cosine of x. This is basically a fraction times a fraction. So I'm going to multiply the numerator with the numerator, denominator with the denominator. So this will equal to cosine of x over the ln of 3 times the sine of x. Now we can actually further simplify this because cosine over sine is equal to cotangent. So my final answer for y prime is going to be cotangent of x over the ln of 3. Let's practice with a few more. We have y equals 5 raised to the x squared. My base here, a, is 5. My u is the exponent, which is x squared. And so u prime would be 2x. My derivative would be y prime is equal to ln of the base, so ln of 5, times the exponential, whoops, I wrote that a little funky, excuse me, times 5 raised to the x squared, and then times the derivative of the exponent, which is 2x. This will be my answer. I like to clean it up a little bit just by moving this to the front, but either way, however you choose to write it would be fine. Moving on to this logarithmic function. In this case, even though I don't see my base here is 10. Anytime you have log without a base written, the base is always going to be 10. U is everything that is inside of log, which is x plus 3 raised to the x. U prime would be 1 plus, now this is an exponential, the derivative of 3 to the x, that's the ln of the base, times the exponential. Putting this together, we get that f prime of x is equal to, now remember we're following this format here. This is 1 over the ln of 10, which is my base, times what's inside of ln, so x plus 3 to the x, times the derivative that we got, the u prime, which is 1 plus ln of 3 times 3 to the x. We can now condense this because this is going to go in the numerator since it's over 1. So my answer for my derivative would be 1 plus the ln of 3 times 3 to the x all over the ln of 10 times x plus 3 to the x. Moving on to C, we have g of x is equal to 4 raised to the 3 minus x squared. My base here is 4. My u is my exponent, which is 3 minus x squared. The derivative of 3 minus x squared is negative 2x. Now let's put this into the derivative format. G prime of x is going to equal to the ln of the base, so ln of 4, times the exponential times the derivative of the exponent. This would be my derivative, which I'm going to clean up and just write it as negative 2x ln of 4 times 4 raised to the 3 minus x squared. For this final logarithm, we have log base 2 of the cube root of 2x plus 1. Before you find any derivative, if you have a root, you're going to need to rewrite it using the rational exponent. So I'm going to go ahead and do that in a different color. I'm going to do that over here just to save some space. This is log base 2 of 2x plus 1 raised to the 1/3. Now, according to my properties of log, if you have an exponent that is, or rather, if you have what's inside of log raised to an exponent, that exponent can be moved to the front and will become a coefficient. So I can once again rewrite this as 1/3 log base 2 of 2x plus 1. This is going to be much easier now to find the derivative because if I were to assign all of this as u, then I would have to use a chain rule in order to get u prime. But since I moved the exponent to the front, I don't have to use the chain rule. So now here my base is going to be the 2. The u is what's inside of log, so that's the 2x plus 1. And u prime is the derivative of u, which is 2. So let's put this all together. We have this 1/3, remember that's a coefficient, so it's going to tag along, times. Now the derivative of log is 1 over the ln of the base times what was inside of log, which is the 2x plus 1, times the derivative of the 2x plus 1, so the u prime, which is 2. Because this is 2 over 1, now we can multiply all of these fractions together. So we have a numerator 1 times 2, which is 2, all over 3 ln of 2 times 2x plus 1. And this would be my derivative, the h prime of x. Let's have a look at finding the equation of a tangent line when you're given an exponential. No matter what kind of function you're given, you should always be ready to find the equation of that tangent line. Remember that for the equation of the tangent line, we always need two things. First, we need the point of tangency. So I need f of 2 in this case, since I'm given f of x is 6 to the x, and we want to write the equation when x is 2. So we plug in the 2 into this equation. So it'll be 6 squared, which is equal to 36. So my point of tangency is going to be 2, 36. This is my x and my y for my tangent line. Now I need my derivative, f prime of x. The derivative of 6 to the x, this is your basic exponential function, where my base here, a, is 6, my u is x, and u prime is 1. So my derivative is going to be the ln of the base times the exponential, which is 6 to the x, times the derivative of x, which is just 1. So this is my derivative. Now we're going to plug in 2 so we can get the slope when x is equal to 2. And that's going to be the ln of 6 times 6 squared, which gives me the ln of 6 times 36, which I can rewrite as 36 ln of 6. I don't know what this number is, so I'm going to keep it just like this. This whole thing is my slope. So now the equation is going to be y minus my y value, so 36, is equal to my slope, 36 ln of 6, times x minus my x value, which is 2. And this will be the equation of my tangent line. Now let's practice a word problem. And this, of course, you're going to need to use the calculator. So when we use the calculator, make sure that you're careful with all of those decimals. Your parents bought you a brand new car at graduation. Assume that the value of the car is given by the function v of t is equal to 25,000 e raised to the negative 0.1 t, where v is the value in dollars of the car and t is the time in years from the date of purchase. How much was the car worth at the dealership? If the car was at the dealership, that means that we haven't bought it yet. And t represents the time in years from the date that we bought it. So that means that here, t is equal to 0. I have not bought it yet, so I want to know how much the car was before I even bought it. So that means that we're solving for v of 0, since I'm looking for the value of the car. So we're going to plug in 0 directly into the function. So that's 25,000 e raised to the negative 0.1 times 0. Now this is going to be 25,000 e raised to an exponent of 0. Anything raised to an exponent of 0 is equal to 1. So this whole thing here is 1. So that means that the value of the car is 25,000 times 1, or just $25,000. For part B, it says how much did the car depreciate during its 4th year? This means that we're looking at how much did the car decrease in value during the 4th year alone. In order to know how much it depreciated, we need to know what the value of the car was at the end of the 3rd year, so I know how much it was worth then, and then find out what the value of the car was at the 4th year, and then we would subtract. Because like that, then we know how much it went down during that 1 year. So for this question, I need to find V of 3 and V of 4. V of 3 is going to be 25,000 times e raised to the negative 0.1 times 3, which is negative 0.3. So I'm going to go to my calculator, and I'm going to put 25,000 times e raised to the negative 0.3. And that gives me 18,520 and 46 cents. Now here I am rounding because this represents dollars, and we only have 2 decimal points for dollars. So 18,520 and 46 cents. Now we're going to get V of 4. So that's going to be 25,000 e raised to the negative 0.1 times 4, which is negative 0.4. So again, I'm going to come here to my calculator. I'm going to do 25,000 e raised to the negative 0.4, which gives me 16,758 and 0 cents. And now we're going to subtract. So we're going to do 18,520.46 minus 16,758 and 0 cents, and that's going to give me 1,762 and 46 cents. So this is how much the car depreciated during that 4th year. For C, when you graduate from college, what is the instantaneous rate of change in dollars per year of the value at t equals to 4? So instantaneous rate of change is just another name for the derivative. And think about it, rate of change is slope. So instantaneous means at that particular moment, what is the slope, or what is the rate of change of the value? So in order to figure this out, we're going to have to find v prime of t. And once we find v prime of t, then we're going to plug in t is equal to 4 to see exactly how it's changing during that 4th year. So let's look at my function. Remember, 25,000 is a coefficient, so it's going to tag along. And now I'm going to multiply by the derivative of e. The derivative of e is the derivative of the exponent times the exponential itself. The derivative of negative 0.1t is negative 0.1 times the exponential, so e raised to the negative 0.1t. Now I'm going to plug in the 4. So v prime of 4 is going to equal to 25,000 times negative 0.1 e raised to the negative 0.1 times 4, so negative 0.4. So let's go ahead and put that into the calculator. We got 25,000 times negative 0.1 times e raised to the negative 0.4. Oops. And we get negative 1,675 and 80 cents. So even though I didn't ask for it, what this means is that the car, the value of the car is decreasing because the derivative is negative by 1,675.80 cents per year when t is equal to 4. The last question is, when will the value of the car reach $12,500? So in this case, we are solving here for t. And this 12,500, this is v of t, since that is the value of my car. So I'm going to go ahead and get my equation here and substitute v of t with 12,500. And that's going to equal to 25,000 e raised to the negative 0.1 t. So we need to solve for t somehow. But I have this coefficient, so what I can do first is divide that 25,000. So I'm going to go ahead and go to my calculator. I have 12,500 divided by 25,000, and I get 0.5. And that equals to e raised to the negative 0.1 t. Now I need to remove t from this exponent. In order to do that, e needs to get canceled out. And the function that cancels e out is ln. So that means that I'm going to apply ln to both sides. So that way it cancels out. So here, ln of e will cancel. Remember when we've done that in our previous lesson, ln and e are inverse functions and therefore cancel each other out. And when they cancel, you would be left with the exponent, which is no longer an exponent. So negative 0.1 t is going to equal to the ln of 0.5. Now I'm going to divide by negative 0.1. And that's going to be my value of t. So we're going to go ahead and put that into the calculator. We got here the ln of 0.5 divided by negative 0.1. And we get 6.9314. This is in years. So what this means is that the value of the car is going to reach 12,500 during its 7th year. So in 7 years. And that's our lesson on derivatives of bases other than e. Even though we did this word problem with e, just wanted to review that.